In this time we will use the sigmoid unit. I think you can still remember that we have the summation unit and we have some figure like this, right? What is the meaning of this side? Once you have the summation, this one can be summation of wi for all I. For the perceptron that you have just used, if the summation is less than 0, the result is negative class, that is 0, right? If it is greater than 1, the result will be 1. So this is the output of our neuron, right? But can you remember we have a function like an S-curve like this, right? And the sigmoid function, the nature of sigmoid function, if it's less than 0, it is like almost 0. If it's less than 0, like minus 100, it will be very close to 0, right? But if it's greater than 0 and much greater than 0, it becomes closer to 1. Can you see? So this one is the sigmoid function. So the result of sigmoid function will be almost same as the result from this kind of perceptron. This kind of perceptron, we call it threshold logic neuron, the one that used or TLN. This one, TLN, threshold logic neuron. It has W0, X0 is 1, and this is W0, W1, X1, X2, W2, and Xn, Wn. Okay, so we can change it to this part, just only this part. We can change it to sigmoid. So the result will be like this. The same thing here. X1, W1, and X2, W2, and finally Wn and Xn. This is a summation, and this is the sigmoid result. It will be like this. Okay, so it becomes the sigmoid unit. How to train the sigmoid unit? It is quite simple. All Wi will be Wi plus delta Wi. While Wi is learning rate, eta, times target minus output, times 1 minus output, and times xi. This one is the training rules for the perceptron. Very important too. So I'll show you the result of perceptron training in our spreadsheet and Python. So guys, I hope that you will understand this rule easily by using the spreadsheet and the Python. See you in the next video clip.